All right, let's talk Kubernetes. We're going to go on a journey from start to finish through the entire life cycle of the most fundamental building block in the whole system. This is the life and times of a Kubernetes pod. Let's get right into it.
So first up, what is a pod really? Well, you can think of it as the atom of the Kubernetes universe. It's the smallest thing you can actually deploy. The best analogy? It's like a single, disposable worker designed to hold your application containers. Everything you build on Kubernetes starts right here, with the pod.
Okay, but here's the thing you absolutely have to understand. The one thing that changes everything. Pods are not meant to be precious. They're not built to last. They are, by their very nature, disposable. They're ephemeral, and grasping this one concept is the key to unlocking how Kubernetes builds such incredibly resilient systems.
So here's our game plan. We'll start by really digging into what ephemeral means in this context. Then we'll watch a pod get created and spring into action. After that, we'll see how Kubernetes plays doctor to keep it healthy. And finally, we'll witness a pod's last graceful moments.
You know, every single pod that's ever created gets a unique ID, a UID. It's like its own personal serial number. And for its entire singular life, that pod is stuck to one specific node in your cluster. It lives there, it works there, and eventually it dies there. It never ever moves.
So how does a pod even come into existence? It's not magic. It starts as a simple blueprint, just a definition in a YAML file. And Kubernetes takes that blueprint and turns it into a real, live, running process. Let's trace those first few steps.
A pod goes through a few distinct phases, and it only ever makes this trip once. First, it's pending. That just means the cluster has said, okay, I've got your request. Then, the scheduler kicks in and the pod becomes scheduled. It's been assigned a home on a specific node. If you have any special setup containers, they run during initializing. And finally, the moment we've been waiting for, when your main app containers are up, the pod is officially running. Now, let's zoom in a little. Even when the pod is in that running phase, the containers inside it have their own little statuses. A container could be waiting, maybe it's busy pulling down a big image. Hopefully it's running, just humming along doing its job. Or it might be terminated, which means it either finished what it was doing or it crashed. Kubernetes is keeping an eye on all of this all the time. So, our pod is up and running. Awesome. But the work is far from over. In fact, this is where Kubernetes really shines. It now puts on its doctor's coat and starts its rounds, constantly monitoring the pod's health, ready to jump in at the slightest sign of trouble. And what's the main tool in that doctor's bag? It's something called a probe. Just think of it as a little health checkup. The kubelet, which is the Kubernetes agent on the node, periodically runs this diagnostic on a container to make sure it's still healthy and doing what it's supposed to be doing. Now, there are two main probes you'll use all the time. The liveness probe asks a very simple question. Hey, are you still alive in there? If that probe fails, Kubernetes assumes the app is broken. Maybe it's in a deadlock, and it restarts the container. Then there's the readiness probe. It asks a different question. Okay, you're alive, but are you ready to take on work? If that fails, Kubernetes is smart. It leaves the pod running, but stops sending it any new traffic until it's ready again.
Oh, and there's one more, a special one for those apps that take forever to start up. The startup probe basically tells the other two probes, hey, just chill out for a minute, give this app some time to get its act together before you start poking it.
Okay, now for a status that gives a lot of people nightmares. Crash, loop, back off. You've probably seen it. It sounds bad, right? But it's actually Kubernetes trying to be helpful. All it means is that a container keeps trying to start, immediately crashing, and then getting restarted over and over again.
And the back-off part is the genius here. See, instead of just hammering the system by restarting a broken container a million times a second, Kubernetes gets smarter. After a few quick failures, it waits 10 seconds. Fails again? Now it waits 20 seconds, then 40. It backs off exponentially, which protects your whole system from a single rogue container.
So if you see this, where do you even start looking? Well, it's almost always one of these usual suspects. Could be a bug in your code, a typo in an environment variable, a required config file that's missing, or maybe you're just not giving the poor container enough memory or CPU to actually run.
The beautiful thing is, you get to control this behavior with something called the restart policy. The default is always, which means Kubernetes will restart the container no matter why it stopped. On failure is a bit pickier. It only restarts if there was an error. And never is exactly what it sounds like. You get to decide what happens.
Okay, so every pod's life must come to an end.
But in the world of Kubernetes, this isn't some chaotic, messy affair. It's an orderly, carefully choreographed process designed to protect your application and the system as a whole.
Check out this timeline. The second a deletion request comes in, Kubernetes sends the container a term signal. That's the polite way of saying, hey, it's time to wrap things up. Then it gives the application a grace period, usually 30 seconds, to save its work and shut down cleanly. Only if the app ignores that polite request does Kubernetes bring out the hammer and send a forceful kill signal.
And this brings us full circle, right back to that core principle. This quote from the official doc says it all. A pod is never rescheduled. It's never moved. That pod, with its unique ID, is gone forever. Instead, it is replaced by a brand new, almost identical one.
And look, this is the proof. Right here, the old pod that was terminated had the unique ID ABC123. The new one that's now running, even though it has the exact same name, has a completely different unique ID, XYZ456. It's a brand new instance. It's a replacement, not a resurrection.
So you might be wondering, who's managing all of this replacing? Well, that's the job of higher-level things called controllers. You've probably heard of deployments or replica sets. Think of a controller as the factory manager. It doesn't care about any single worker pod. Its only job is to look at the factory floor and make sure the right number of workers are always on the job. If one goes down, the manager just hires a new one instantly.
So let's just nail down the big takeaways here. Pods are disposable. They live one life. Kubernetes uses probes to keep them healthy. The restart policy lets you control how to handle failures. And remember, the real resilience comes from controllers managing those disposable pods, not from the pods themselves. And finally, that graceful termination is key for stable applications.
And that really leaves us with one final big question. Now that you truly understand that your pods are designed to disappear at any second, how does that change the way you build your software? It forces you to stop trying to prevent failure and start designing for it. So, how are you going to build your next app to be truly resilient in a world where nothing is permanent?